Welcome everyone to another deep dive. This time we're tackling something that I think is going to be super relevant for a lot of you out there. .NET. Now, you're probably thinking, .NET, isn't that been around forever? And yeah, you'd be right. But here's the thing.
It's changing big time.
Exactly. And that's what we're digging into today. We're going to see how .NET, this veteran framework, is adapting and evolving with these crazy new cloud technologies.
Yeah, stuff like AI, edge computing, even quantum computing. We're going to see how .NET is not just keeping up, but actually opening up all these new opportunities. It's a pretty exciting time.
Totally. So by the end of this deep dive, you'll have a much better idea of how .NET is shaping up in this new landscape. And more importantly, what it means for you as a developer. Whether you're already deep in the .NET world or just kind of curious about it, this one's for you.
Absolutely. It's about staying ahead of the curve and understanding where the tech is headed.
All right, so let's start with the basics. Where does .NET stand right now in the whole cloud ecosystem? We've got a ton of sources here, and they all seem to agree that .NET is already a major player when it comes to building cloud applications. What makes it such a good fit for the cloud?
Well, I think one of the biggest things is how well it integrates with all the major cloud platforms, especially Microsoft Azure.
Right, Azure. That makes sense.
It's like a perfect match. .NET has always been known for being robust and scalable, and Azure provides that whole infrastructure to really make those qualities shine.
So it's like .NET provides the tools and Azure provides the playground, and together they let you build these really powerful cloud applications.
Exactly. Applications that can handle huge amounts of data, scale up or down as needed, and stay secure. It's a solid foundation.
A solid foundation. Okay. But the cloud itself is changing so rapidly, right? It's not just about servers and data centers anymore. AI is everywhere. Edge computing is gaining traction. Quantum computing is on the horizon. It seems like almost every industry is being touched by these technologies.
Absolutely. And that's the big question for .NET. How does it adapt to this new world where the cloud is becoming so much more than just a place to store data?
That's what we're here to unpack.
Hmm.
So let's start with AI. Seems like you can't go anywhere these days without hearing about it. Our sources show that .NET developers are finding it easier and easier to integrate AI into their applications. What's driving this shift?
I think a big part of it is the availability of these platforms and libraries that make AI way more accessible. You don't need to be a data scientist to start using AI in your .NET applications anymore.
That's pretty huge.
Uh,
So what are some of these platforms and libraries that are making AI so much easier to use?
Well, a great example is Azure Cognitive Services. It's like this suite of pre-built AI models that you can just plug right into your .NET application.
Plug and play AI. I like that.
Exactly. Things like natural language processing, image recognition, even predictive analytics. You can add these features without having to build the whole AI infrastructure from scratch.
So say I'm building a .NET application for customer support. Could I use something like Azure Cognitive Services to analyze customer queries and automatically route them to the right person?
You absolutely could. Or you could use it to understand the sentiment of customer feedback. Are they happy? Are they frustrated? That kind of thing. It can really help you build a much more responsive and intelligent application.
So that's using pre-built AI models.
Yeah.
But what about developers who want to create their own custom AI models? Is that something that .NET supports as well?
Absolutely. That's where ML.NET comes in. It's an open source machine learning library specifically designed for .NET developers.
ML.NET. Okay, so with ML.NET, you can actually build and train your own custom AI models without having to be a data science expert.
Exactly. You can use your existing .NET skills to build models for things like fraud detection, customer churn prediction, or even personalized recommendations. It really opens up a whole new world of possibilities for .NET developers.
That's pretty amazing. So we've got these pre-built AI models with Azure Cognitive Services and the ability to build custom models with ML.NET. It seems like .NET is really well equipped for this AI-driven future.
It really is. It's giving .NET developers the tools they need to build the next generation of intelligent applications.
Okay, so we've talked about AI. Let's move on to another big trend in cloud computing, edge computing. Now, this is where things get a little bit more, out there. For our listeners who might not be familiar with edge computing, can you give us a quick rundown of what it's all about?
Sure. So edge computing is all about moving data processing away from centralized cloud servers and closer to the source of the data itself. Think of it like this. Instead of sending all your data to the cloud to be processed, you process it right there on the device or on a local server.
Okay, so why is this so important? What are the advantages of processing data at the edge?
Well, one of the biggest advantages is speed. When you send data to the cloud, there's always going to be some latency. That's the time it takes for the data to travel back and forth. But with edge computing, you eliminate that latency because you're processing the data right where it's generated.
So it's all about reducing latency. And that's especially important for applications where real-time decision-making is critical, right?
Absolutely. Think about things like self-driving cars or industrial automation. In those situations, even a tiny delay can have huge consequences. Edge computing allows you to make decisions in real time without having to wait for data to travel to the cloud and back.
That makes a lot of sense. So how does .NET fit into this whole edge computing world?
Well, Microsoft has this platform called Azure IoT Edge, which is specifically designed for building and deploying .NET applications on edge devices.
Azure IoT Edge. Okay, so it's like a specialized version of Azure that's made for running .NET applications on the edge.
You got it. It provides all the tools and infrastructure you need to build, deploy, and manage your .NET applications on a wide range of edge devices.
Can you give us some real-world examples of how .NET and edge computing are being used together?
Sure. One example is in manufacturing. You could have a .NET application running on an edge device that's connected to sensors on a factory floor. The application could monitor the data coming from the sensors in real time and trigger alerts if it detects any anomalies that could indicate a problem with the equipment.
So it's like having a mini data center right there on the factory floor, analyzing the data,
Yeah.
making decisions in real time.
Exactly. And because it's all happening locally, you don't have to worry about the latency of sending data to the cloud and back.
That's really cool. It seems like edge computing has the potential to revolutionize a lot of industries.
Mm.
So what do you think the future holds for .NET and edge computing?
I think we're going to see even tighter integration between .NET and edge computing platforms like Azure IoT Edge. We're also likely to see more specialized tools and frameworks that are specifically designed for building and deploying .NET applications on edge devices.
So it's a growing area for .NET developers to keep an eye on.
Definitely. It's an area where .NET can really shine and where there's going to be a lot of demand for skilled developers.
All right. So we've covered AI and edge computing. Now let's talk about something that's a little bit more, I don't know, futuristic. Quantum computing. Our sources indicate that even in this really advanced field, .NET is starting to make its presence known. For our listeners who might not be familiar with quantum computing, can you give us a quick explanation of what it is and why it's such a big deal?
Well, think of it this way. Traditional computers, the ones we use every day, they use bits to represent data. A bit can be either a 0 or a 1. But quantum computers, they use qubits. And a qubit can be a 0, a 1, or both at the same time.
Both at the same time.
Yeah.
That's where my brain starts to melt a little bit.
Yeah, it's pretty wild. But that's what makes quantum computing so powerful. Because qubits can be in multiple states at once, quantum computers can perform calculations much faster and solve problems that are simply impossible for traditional computers to handle.
So we're talking about solving problems that are way beyond the capabilities of even the most powerful supercomputers we have today.
Right, exactly. Things like developing new materials, designing life-saving drugs, or breaking the encryption that protects our online data. Quantum computing has the potential to revolutionize a lot of fields.
It sounds like something straight out of science fiction.
Yeah.
So how does .NET fit into this quantum world?
Well, Microsoft has been developing this platform called Azure Quantum, which is designed to make quantum computing accessible to a wider audience, including .NET developers.
Azure Quantum. So it's like Azure, but for quantum computing.
Yeah, you could think of it that way. It provides access to different types of quantum computers and a bunch of tools for developing quantum algorithms. And one of the key tools for .NET developers is a programming language called Q#, or QShack to rep.
QShack. So this is a programming language specifically designed for writing quantum algorithms.
That's it. And the great thing is QShack integrates really well with the .NET ecosystem. So .NET developers can use their existing skills and tools to start exploring the world of quantum computing.
So you're saying that a .NET developer could potentially write a quantum algorithm using QShack and then run that algorithm on a quantum computer through Azure Quantum.
Exactly. And while quantum computing is still in its early stages, it's moving fast. By learning QShack now, .NET developers can position themselves at the forefront of this exciting new field.
So for our listeners who are .NET developers, what would you say are some practical steps they could take to start preparing for this future where AI, edge computing, and quantum computing are becoming more and more prevalent?
I would say the first step is just to start learning. There are tons of resources available online. Microsoft has great documentation and tutorials for things like Azure Cognitive Services, ML.NET, Azure IoT Edge and QShag. There are also a lot of online courses and communities where you can connect with other developers and learn from their experiences.
It sounds like it's all about taking that first step and just diving in. And you don't have to become an expert overnight. Just start exploring and experimenting with these new technologies.
That's the key. The more you learn and experiment, the better prepared you'll be for the future of .NET and cloud computing.
It's been really insightful talking about all of this. And I think the takeaway for our listeners is that the world of .NET is changing rapidly, but it's also incredibly exciting. With AI, edge computing, and quantum computing on the horizon, there are so many opportunities for .NET developers to innovate and build the next generation of applications.
Absolutely. And the tools and resources are out there. It's up to developers to take advantage of them and be a part of shaping the future of technology.
Well said. As always, thanks for listening to The Deep Dive. Now, for you, our listener, I want you to think about this. How might these emerging technologies impact your own work or your industry? What new possibilities do they open up? It's a question worth pondering as we move into this new era of computing. Thanks for joining us.